All right, welcome again, guys, to G Squared Academy, where excellence is epitomized. All right, exams are coming up, and I just want to go through a couple of things with you guys. But before I do that, I want to thank everyone for subscribing to the channel. Thank you for the likes. Thank you for the comments. Thank you for all the support. I really appreciate those comments that you guys pass on, about the videos. And I'm happy that they're helping you guys. And that's the key thing, you know what I mean? So we want to continue to help you guys so that you can be successful. So what we want to do today is we want to look at qualitative analysis. All right. So as you can see on the screen there, qualitative really is asking the question, what is it? What is it that I'm looking at here? You go to a crime scene and you generally see these things on like CSI. They go to a crime scene, they find a substance, now they need to determine what this substance is. What is it? In chemistry, the process of finding out what it is called qualitative analysis, right? Versus quantitative analysis. So don't mix up the two things. Quantitative asks the question, how much is it? So you find a substance, qualitative says, what is it? Quantitative says, how much is it? All right. Now, for your purposes at CSEC level, or there is qualitative, may be divided into organic, which you'll do at the CAPE level, or inorganic, which is done at the CSEC level. So your focus now is inorganic qualitative analysis. All right. And for inorganic, we mean you're really trying to identify ionic compounds and the species produced from these ionic compounds, gases or whatever else that may be produced. So you're inorganic, you're trying to identify an ionic compound. And of course, an ionic compound is made up of a cation and an anion. All right. And of course, you may get some gases depending on the situation. So your thing is not that bad. So let's look at the gases first. The gases that you're being asked to identify are ammonia, carbon dioxide, sulfur dioxide, and nitrogen dioxide. Now, I place these arrows here just to show you where these gases come from as an indication of the ion that you will get them from. Remember now, you're doing qualitative, so you're trying to identify a cation and an anion. Okay, so you have to use all the pieces of information you have to determine which cation and which anion is present. So what we're saying is that if you get ammonia gas, that gas must have come from the ammonium ion. There's nothing else it's going to come from. If you get carbon dioxide, it's going to come from the carbonate ion, sulfur dioxide, sulfite ion, and NO2, you're going to get that from the nitrate ion. So how do you know you have ammonia? Well, here's the thing. Ammonia is the only common alkaline gas. And if it is an alkaline gas, then it's going to change red litmus paper to blue. It's actually the only gas that's in that, for your purposes, that's going to change red litmus to blue. Most other gases are going to change blue litmus paper red. How do you know you have carbon dioxide? It's an other colorless, odorless gas. However, it turns lime water, which is calcium hydroxide, cloudy. Okay, and also carbon dioxide will extinguish a glowing splint. That's why they use carbon dioxide in fire extinguishers, because they extinguish fires. Makes sense, right? Now, how do you know you have sulfur dioxide? Sulfur dioxide comes from the sulfite ion, and is a gas with a choking odor. There it is. It's a gas with a choking odor, and it decolorizes acidified potassium permanganate. And it could also decolorize acidified dichromate as well. Well, not decolorize, but change it from orange to green. Okay, and it will also change and be red in litmus. So that means it is an acidic gas. And of course, this litmus is going to be damp litmus because it needs to dissolve to form the acid. So what about the nitrate now? Up here, you can see the nitrate producing the nitrogen dioxide. How do you know you have that? Well, this one is probably the easiest because it is brown. It is a brown gas. That is like the biggest thing about it. And it changes blue litmus to red. So it's also acidic. Okay, so those are the gases that you really need to identify when you are doing qualitative analysis at the CSEC level. Okay, so let's go back up to the top. So up at the top now, what we have here is that we have the cations. Which cations? So the cations that you need to know now, right, Sodium, ammonium, there should be a 4 there for the ammonium. Don't know why that is eaten off, right? Potassium, calcium, magnesium, aluminum, zinc, iron 2 and iron 3, zoomed out there, iron 2 and iron 3, and then you have lead and copper. So you'll notice that I have some little things beside those ones. All right, so what we're trying to say here is that some of these ions, these cations, are going to be colored in solution. So copper, for example, copper 2 is going to be blue. Iron 2 is going to have a pale yellow color in solution. Very hard to see, to be honest. And iron 3 has a rusty brown color because iron 3 is what is the major ion in rust. So therefore it has a brownish color. You know what rust looks like. The rest of the ions up here usually are not colored, so it's difficult to identify them. However, how do you determine the cation present? So all you really need to do for the cation is react it with sodium hydroxide, dropwise, right? And then you add extra or excess sodium hydroxide. Okay, notice I put the letters XS because it is acceptable to write excess in your exam. And then after that, no. So what you're trying to do here is you are trying to identify a substance. Now, in science, generally speaking, when you're trying to identify things, you need to have a backup plan. Okay, so if you identify it one day and say, okay, you know, it is lead nitrate, for example, you need to be able to say what secondary pieces of evidence did you use to determine that it is really lead nitrate? Because you may have made a mistake in the first one, may have, it doesn't have to be, but you need to have secondary pieces of evidence. So sodium hydroxide really says, okay, it is possibly this. Then now you add ammonia, aqueous ammonia, of course, which is ammonium hydroxide, dropwise, and then in excess. And that really confirms or denies what you have. And then after that, there are other confirmatory tests for these cations as well. So you can do further tests to solidify that you have certain ions present. For example, if it is that you think you have lead and you want to confirm that you have lead, you could react that substance, that solution with potassium iodide. And if you get a bright yellow precipitate, you know that you have lead present there. Okay, so that is how you would test for your cations. All right, so now let us look at the anions. The anions that you need to identify at this level would be the sulfate, sulfide, carbonate, nitrate, chloride, bromide, and iodide. And these are halides, of course. Okay, so let's look at these three up here first, because we can use one reaction or two to identify these ones. Okay, so basically what you're going to be doing with these is you're going to be reacting the solution with barium ions. See right there, barium 2 plus ions. The barium 2 plus ions generally come from barium nitrate or from barium chloride, because those two salts are soluble in water, so they would provide barium ions. Of course, when you react this, you usually, if one of these are present, you're going to get a white precipitate. Okay, you get a white precipitate. And then after that, you're going to react the solution with acid. H plus, of course, represents acid. And if it reacts with the acid, then you know it is possibly sulfate, sulfite, or carbonate. If the white precipitate reacts with the acid, it's possibly carbonate or sulfate. Whether it is carbonate or sulfate, you go back over here. Okay, see, if it's carbonate, you get carbon dioxide, which turns lime water cloudy. If it is sulfite, you get the sulfur dioxide ion, which is a gas with a choking odor. That is easy to detect because you're going to feel like you're being choked. Okay, so you use barium ions to determine which one of these you have present. The nitrate is probably one of the easiest because it produces nitrogen dioxide, which is a brown fumes. It's a gas with a brown fumes on heating. Okay, or you can use copper turnings in conch sulfuric acid to produce that brown fumes as well, and as well as a blue solution. So nitrate, the easiest way though for nitrate you're looking at is heating the solid, and if you get brown fumes, then you know that nitrogen dioxide is being produced, and that must come from the nitrate ion. For the halides now, The halides, what you do is you react your halide solution with silver nitrate, usually silver nitrate ions, and then you add ammonia. Sometimes they put the solution in the sun to see what would happen. But more often than not, when you add your silver, then in excess, you get your precipitate usually if a halide is present, and then you add your ammonia. You do your ammonia solution, and that will confirm the presence of whatever halide you have. Okay. One gas I forgot to mention though, guys, is oxygen gas over here. I totally forgot about oxygen gas, which of course, you know, oxygen relights a glowing splint. So that one is pretty easy. It's an odorless, tasteless gas, but it relights a glowing splint. Okay. So this is the first part in this exam prep series. So you're going to then, after this video, you're going to see another video about working qualitative questions. So you should look out for that video, because this is just the content. So after you learn the content, now go and work some questions, and I'll do a video for that, and you'll see how the questions are worked so you can answer them. Okay.